Okay, so note that first of all, this is an odd function. It's got horizontal asymptote. The x-axis is the horizontal asymptote. So when it's equal to 1, it's equal to half. Okay, so it's going to look something like this. Okay, it's an odd function, so it's going to be a symmetrical image on this side as well. Okay. Actually, it doesn't have a vertical asymptote, right? I just realized that I was interpreting it as a minus, but it's plus. This is always greater than or equal to 0. So when it's actually equal to 0, it's 0. Okay. So it looks more like this. It goes up and comes back down. It goes down and comes back down. Okay, and then y equals mx. So that's it's just a line. Okay, the question is, what does the slope have to be, or what range, what values of slope will make sure that we enclose a region? So the way I've drawn right now doesn't enclose any region. Okay, but if I drew the line like this, you can see that it encloses this region right here. Okay, so let's consider just the right side, okay, because of the symmetrical nature, right? We don't need to really be considered with the left and the right side. And let's consider that area. Let's do a setup. Okay, from 0 to the intersection point between this and this. So let's do that here. X over x squared plus 1, mx. Bring the mx over. Okay, factor out the x, and you get 1 over x squared plus 1 minus m. Okay. You get x squared plus 1, you get 1 minus m, x squared plus 1. Okay, let's set that numerator equal to 0 for the root. So you get mx squared minus m is equal to 0. So minus mx squared is equal to m minus 1. Okay, and multiply both sides by -1 to get 1 minus m. So x squared is equal to 1 minus m over m. So x is equal to the root. And I only need to consider the positive value because we're only looking at to the right of the y-axis. All right, so it's pretty complicated. This right there, the x value there is the root of 1 minus m over m. So we're integrating from 0, root of 1 minus m over m. Okay, and the top graph is this. So it's x over x squared plus 1, and the bottom is a line. Okay, and we want this, right, to be positive. Right? It can't be 0, it can't be negative. All right. Separate this to two separate integrals, x over we want this to be positive. Just going to omit the integral intervals from 0 to this m expression. Here, if you let u equal to x squared plus 1, you get du is equal to 2x dx. So that x dx can be replaced with half of, right, du. Okay, so then this is easy, right? It's going to be just times by half x squared. Okay, it's half of ln of absolute value of u. We don't need the absolute value because u is equal to x squared plus 1, which is always positive. Okay, now we're going to plug this in. Okay. Fortunately, the x is squared, so we're going to get ln of, right, 1 minus m over m plus 1 minus m over 2, 1 minus m over m. Okay, this has to be positive. Okay, let's see. We can simplify this here. So this actually just becomes ln of 1 minus m plus m, so you're going to get just ln of 1 over m. That cancels out, and multiply the negative n, you get m minus 1. At this point, we know that this is not something that we can solve algebraically, so we're going to need some graphing device assistance here. So I'm going to graph this on Desmos. Okay, this graph right here, it looks like this. So the question is, when is this positive, right? What's positive right here and right here, right? So that means when m is greater than 0, but less than 0.203, or when m is greater than 1, okay, this here is positive. If you go back to the actual question and inspect this, clearly slope cannot be greater than 1, because if it is, right, if it's 45 degrees like this, that's not going to enclose any area there. So it must be some extraneous answer we got by manipulating this integral. So the answer that we're looking for is this one right here.